So let's take a look at some examples. The first example that we're going to be looking at is 30 meters. Now the only length that's a vector is displacement. So this right here is 30 meters displacement in some direction. We're not talking about direction right now. So let's just talk about how to scale this vector. To scale this vector, we can go with a couple of choices. You can either go with 6 meters gives you 1 centimeter, in which case you're going to get 30 divided by 6 is 5 centimeters, or you can go with 5 meters gives me 1 centimeter, in which case 30 divided by 5 is going to give me 6 centimeters. So now you're essentially going to draw a vector or an arrow of length 5 or 6 centimeters. Any of these two scales is going to be fine. The next one is 12 meters per second square. Of course, that's acceleration. And again, the scale for this is pretty obvious. You can use 2 meters per second squared gives you 1 centimeter. So you're going to get 12 divided by 2, which is going to give me 6 centimeters. So the next example is 0.45 newtons. Now 0.45 newtons, it's not going to be easy to scale, right? Why? Because it has decimal places. So the first thing that I do when I'm scaling vectors like these are I completely ignore the decimal places. If I ignore the decimal places, it becomes 45 newtons. All right. And then I can put the decimal places back again. So that's not a problem. So essentially what we have is I need to scale 45 newtons. So I can either use a scale where I have 9 newtons give me 1 centimeter, which is going to give me 45 divided by 9 is 5 centimeters. So I can use a 5 centimeter line to represent this vector, or I can go with 5 newtons give me 1 centimeter, and in which case 45 divided by 5 is going to give me 9 centimeters. The next is 40 meters per second. Now this right here is, of course, it's not speed. Why? Because speed is not a vector. So it's got to be velocity. All right. Again, we can use a couple of scales over here. We can use the scale 8 meters per second gives me 1 centimeter, in which case 40 divided by 8 is 5 centimeters. So you can use a 5 centimeter arrow to represent 40 meters per second. Or you can say that, okay, I'm going to use 5 meters per second to represent 1 centimeter. And 40 divided by 5 is going to give me 8 centimeters. All right, so these are just some examples which you can use. So what I want you to do is the next couple of examples you're going to draw on your own, and then we are going to discuss them. So 10 newtons, 0.48 newtons, 7.5 meters per second squared, and 700 meters. So try, attempt these, pause the video, try and attempt these, and then we'll discuss them. So let's go to the 10 Newton vector. So the 10 Newton vector should be simple. The only scale you can use for a 10 Newton vector is 1 centimeter is 2 newtons. All right. I'm sorry, I wrote this the other way around. But that really doesn't make a difference. So 10 newtons divided by 2 should give me what? Should give me an arrow of length 5 centimeters. With 0.48 newtons, you're going to repeat exactly what you did with 0.45. You're going to ignore the decimal places. So let's make this to be 48 newtons. And then I can say, all right, I can use a couple of scales depending on the amount of space I have or the other vectors that are involved. So I can either say that, okay, 8 newtons are going to give me 1 centimeter. So in this case, I'm going to get 48 newtons divided by 8, which is 6 centimeters in length. Or I can say that I'm going to use 6 newtons is 1 centimeter, in which case 48 divided by 6 is going to give me 8 centimeters. For 7.5 meters per second squared, of course, your tables got to be good. Your tables, your multiples, your factors have got to be good. For 7.5, I can either use 2.5 meters per second squared give me 1 centimeter, in which case 7.5 divided by 2.5 is 3 centimeters. Now again, 3 centimeters is like borderline appropriate length. Okay, so maybe depending on the usage in the question or the other vectors involved in the question, maybe I can use it, but again, it's not recommended. The recommended scale that I would use over here is 1.5 centimeters square, sorry, meters per second squared. Meters per second squared should give me 1 centimeter, in which case 7.5 divided by 1.5 is 5 centimeters. Now this right here would be the most appropriate scale. This one right here is generally what I would use when drawing a vector of 7.5 meters per second squared. Then you've got 700 meters. So in 700 meters, what am I going to do? So I can use a ton of different scales over here, but the most obvious one is 100 meters displacement gives me 1 centimeter length of an arrow. So in which case I'm going to get 700 divided by 100 is 7 centimeters in length. Alright, so these right here are just some simple examples of if you have certain vectors, whether decimal places or in decimal points or non-integer values, this is how you're going to scale them. And essentially the type of scales that you can use, we've discussed those already. So I hope that this right here is clear to everyone. That's it for this video. Inshallah, I'll see you in the next one. Bars out.